Okay, then we've got this equation to solve. Okay, we've got a range of values. We can see that x is clearly in radians. There's no mention of degrees. But our problem is that this equation has got a sine x term and a cos x term. So I don't know what sine x is. I don't know what cos x is. I know a relation between them. So we've got two different trig functions when we'd prefer just to have an equation with one. And because there's just a sine x term and a cos x term and nothing else, we can have our wish. The trick here is to know that, okay, we kind of knew that this sheet was going to be, this example was going to be about tan A equaling sine A over cos A for any angle A. So therefore, I've got a sine of x in this case and a cos of x. In order to make sine x over cos x appear, I can divide by cos x, and that's a good plan because it turns this term just into 4. So if we divide through by cos x, well, let's show all the steps. 5 sine of x divided by cos of x. I'm going to divide that term, minus 4 cos of x over cos of x, divide that term, is still equal to 0. So the first term I've got sine x over cos x, so this is going to become 5 tan of x, okay, and this second term is just going to be minus 4 equals 0, okay, and in practice you can go straight from that line to this line knowing that you're dividing by cos x. It's nice if you say that's what you're doing. Okay, how do we go from this bottom line? Well, this is now just an ordinary trig equation. We need to make tan x a subject of it. So if I add 4 to both sides, I'm going to get 5 tan of x equals 4 and divide by 5. So tan of x is going to equal 4 over 5. And we just solve this by the normal procedure. So we need to get our first x, and that's just going to be doing an arctan of 4/5. And make sure your calculator's in radian mode, of course, equals 0.676747. Okay, the 4 after that. We're only going to need 3 significant figures in our final answer, but until we've reached our final answer, keep more than 3 significant figures. We need a second x. Okay, now you can use the graph of tan and the way it repeats, or you can just know that the second solution for a tan is going to be 180, or in this case pi, plus the first solution. So it's pi plus 0.67474. That's still stored on my calculator display, so I just have to add pi to it, and I get my second answer is 3.816. Okay, and then I've got to give my final answers. It's appropriate to give these to 3 significant figures. So we summarize answers at the end. X equals 0.674 and 3.82. And we put 3 significant figures after that, and we're done. So we've got a clear use of division by cos x to use the identity to get a tan x into it, and then we use a normal procedure for solving a trig equation, a first x, a second x, with a clear method for both, and then summarize the solutions at the end. Oh, I should have mentioned, we should always consider whether there are going to be any 2 pi repeats of these first 2 solutions, but because my range of values is 0 to 2 pi, adding or subtracting 2 pi to these would take me outside of that set of values.